Hi all. Now we are going to see how the thyristorized power supply is used for heating in an induction furnace. This is the circuit used for induction furnace or basically induction heating. The amount of heat produced in a metal or a job or work coil, whatever we call, by induction heating process actually depends on three main factors. First one, the quantity of flux coupled by the primary coil, and the second one, the power supply frequency, and the third one is the characteristics of the metal that is supposed to be heated. So based on these factors, the heating quality or the performance varies. Now we'll check, since the frequency is one of the factor, we'll check the high frequency that is or the frequency range that is chosen for the induction furnaces, that to specifically for the melting purpose in the industries. The normal range of frequency chosen for the heating or the melting process or this purpose is from 500 hertz to 50 kilohertz, whereas the medium frequency induction furnace that is normally employed or the frequency range that is employed are 500 hertz to 10 kilohertz. For this frequency range, the thyristorized static power supply that we are seeing now is used. So the three-phase supply is actually converted or changed to a DC by the three-phase rectifier here, and that is used, the ripples in that has been reduced by using a filter, nothing but the LC filter used here, and then inverter is used, which is used to convert this DC to the AC. Okay, so the output of the inverter is actually having a high frequency AC supply, which serves as the input to the induction furnace. And most importantly, the rectifier and the inverter used here are a fully controlled converter. Means we have, it is not the DC, it is the it is not the diode. We use the ACRs here to convert the AC to DC or the DC to AC. So we'll have the provision to control the voltage as well as the frequency. And the voltage level of the supply to the induction furnace varies based on the alpha varied in the or the firing angle that is varied in these ACRs. So we have the control over here. And the current being maintained constant in the overall circuit, the level of the power fed to the furnace can also be varied to the required temperature, and the frequency obtained in the inverter circuit bridge can be varied by adjusting the firing angle here. Uh, the optimum frequency suitable for the furnace can be obtained by such a power supply through this, and the efficiency of this melting process is thereby increased. So if you want to increase the frequency, we can increase or change the firing angle. If you want to change the voltage also, we'll be having the control through the uh, gate circuit or the firing angle of the SCS. Since and the most advantageous factor is we'll not be having any separate commutating circuits or turning off circuit of this SCS in this, because we have this RL combination which actually commutates the SCS, turn off the SCS, and the C is also meant for that, which is actually used for the power factor improvement. So these acts as the commutator circuit or the commutating elements of the, in spite of being the main induction furnace element, this also acts as the commutating elements of the inverter circuit. So this reduces the extra circuit for the commutation part of the inverter. So once the after converting this DC to AC, or the frequency operating frequency is achieved, then we'll move on to the next condition to improve the performance of the induction furnace, or nothing but to maintain the temperature constant in this furnace. So this is obtained by this voltage and current levels, again automatically controlling through this thyristorized bridges here, which is employed here, and the induction coil in series with the resistor maintains the current constant. So this is the purpose. And also the capacitor in parallel is used for the, as I mentioned before, it is used to improve the power factor. So the main feature of this power supply is the inverter circuit does not have any commutating circuit. So this is how we try to use this thyristorized circuit either as a rectifier or inverter to control the temperature or heat or the frequency or the amount of heat produced or the quality or the performance of the heat produced in the induction furnace. Thank you.